Hello and welcome to this video in this series on solubility product. My name is Kim, and in this video we'll be predicting whether a precipitate will form using the information provided in the solubility product quotient QSP and comparing it to the solubility product constant KSP. In a previous video, KSP, or the solubility product constant, was described as a concentration of the products of a dissolution reaction at equilibrium. QSP, or the solubility product quotient, is defined exactly the same way except that it can be at any point in time. Comparing the QSP and KSP will give you an indication of the direction of the dissolution. If QSP is less than KSP, then the solid will be dissolved into ions in solution so that there is no precipitate. If QSP is greater than KSP, then the direction is reversed and ions will come out of solution to form precipitate. This may also indicate supersaturation, which will be discussed in a later video. If QSP is equal to KSP, then the reaction is at equilibrium and the solution has as much ion in solution as it can hold. Let's use this information in the applied question. The applied question asks whether a precipitate will form when 0.3 milligrams of silver bromide is dissolved in 1 liter at room temperature. The question will require calculating the solubility product quotient QSP and comparing it to the given KSP of silver bromide in the question stem. The first step is to write out the dissolution reaction for silver bromide, which dissociates in a 1:1 ratio. Next, write out the KSP expression. So KSP is equal to the concentration of the silver ion multiplied by the concentration of the bromide ion. To calculate the ion concentration, you need the number of moles in the given mass. Moles is calculated by the mass divided by the molar mass, which is equal to the mass of silver bromide, 0.3 milligrams, divided by the molar mass of silver bromide, 187.8 grams per mole. That equals 1.6 times 10 to the minus 6 moles of silver bromide. For every mole of silver bromide that dissociates, the same number of moles of silver ions and bromide ions will dissociate. So the calculated moles from the earlier step divided by the volume of 1 liter will equal the concentration of 1.6 times 10 to the minus 6 molar. Calculate QSP by multiplying the concentration of both silver ions and bromide ions in the previous step. The QSP of 0.3 milligrams of silver bromide in 1 liter is 2.5 times 10 to the minus 12. The last step requires comparing the QSP and the given KSP. Since the QSP is greater than the KSP by almost a factor of 10, you can definitely expect to see some precipitate forming. Great job working through these calculation steps. Feel free to come back to this video and work through the steps slowly and methodically so that you're able to predict the direction of dissolution reactions in your own practice.